Good morning, everyone.
Good morning, ma'am.
Good morning, ma'am.
Okay, I hope I'm audible.
Yeah, ma'am.
Yes, ma'am.
All right, we'll start with today's class. Uh, all of you who are present, enter your attendance. Only the first 48 attendance I am going to consider today. Okay. After that, whoever has given attendance, their attendance I'm not going to consider. All right. Now, in the last class, we had started learning what is data communication. We learned what is the meaning of the word communication. We learned what is short distance and long distance communication. We also learned the meaning of the word data communication and its characteristics. Data communication is the exchange of data between two devices. Okay. Then we learned what are the components of a data communication system. You all can see on the screen: sender, receiver, medium, message, and protocols. These are the 5 components of data communication system. Your data can be text, it can be in the form of numbers, images, audio, or video. Okay. So today what we are going to learn is, in a data communication system, what kind of data flow will be there. Now I hope you understand the meaning of the word data flow. What do you mean by data flow? When we are sending the data, it moves, it goes from one machine to another machine. So when it is being sent by the sender, via the medium, it is being received at the receiver side. Now what is happening? Transmission of data is happening from the sender to the receiver. This transmission of data between two devices, that is from the sender to the receiver, is called as data flow. And whenever we have a data communication system, the data flow can be of 3 types. Means we can transmit the data in 3 ways. Transmission or exchange of information between sender and the receiver can happen in 3 ways. Which are those 3 ways? From the from the sender to the receiver, it can be in the form which we call as simplex. It could be in the form of half duplex, or the transmission of data, the flow of data can be in the form of full duplex. Try to understand this. Between two devices, any two devices, it can be between two computers, two PCs, maybe between a server and a PC, or between a mobile and a mobile, any type of two devices you consider. The flow of data between any two devices can be implemented in 3 ways. One is simplex, second one is half duplex, third one is full duplex. Now, what do you mean by simplex? The data transmission happens in one direction only. Transmission of data happens in one direction only, that is from the sender to the receiver. Data can be only sent from one machine to another machine. The other machine cannot respond. This kind of a mechanism, this kind of a method of transmitting the data is called as simplex data transmission, or the flow of data is said to be simplex. For example, you can see in the diagram, suppose you have a mainframe computer. A huge mainframe computer has got huge processing speed, huge storage capacity. Generally, mainframes are used in large organizations, or maybe in governmental setup for processing the data. So mainframe are similar to servers. They are very huge. They have very huge transmission speed. So imagine there's a mainframe and there's a PC. A PC is a personal computer, maybe a kind of a computer that I and you use, a desktop computer. So from the mainframe computer to the PC, data flow is in one direction. Can you see the direction of data on the screen? From the mainframe, it is being sent to the PC. So it is in one direction since the data flow is only from sender to receiver. It is known as simplex. Now in the diagram, it is shown as mainframe to PC. But that doesn't mean always it is between mainframe to PC. It can be between PC to PC, between two laptops, laptop to laptop, between a mobile and a laptop, any devices. In the example, it is shown as mainframe to PC. What is to be understood there? What you have to understand is that mainframe computer or maybe a sender will send the data to the receiver. The receiver is not allowed or is not going to give any response. So data transmission is in one direction only, hence it is called as simplex. The second type of data flow that we can have in a network based system is called as half duplex. Now half duplex means data flow can be in both the directions, that is from the sender to the receiver and from the receiver back to the sender, but in one direction at a time. That is, at a time only the sender can send or the receiver can send. Both of them will not be able to communicate simultaneously. So in half duplex communication, data transmission happens in both the directions. Can you see the direction of data at time 1 and direction of data at time 2 means a sender will send the data to the receiver. The receiver will then respond by sending an acknowledgement to the sender. Now what is shown in the diagram? It is shown as station and station. Station means workstation. What do you mean by the word workstation? A workstation can be a computer, it can be a laptop, it can be a personal digital assistant. Any terminal via which you can transmit and receive data is called as a station. Generally, it is called as a workstation because you can do your day-to-day activities, day-to-day work on that particular machine. Instead of using the word station, workstation, they have made use of the word station. So understand, the station on the left hand side is the sender. The station on the right hand side is the receiver. Can you see the sender is sending the data to the receiver? Receiver is then responding back. But that what you must understand here is both sender and the receiver can send and receive data. That is, communication can happen in both the directions, but one at a time. Both can't communicate simultaneously. They can only one at a time machine can communicate with each other. Such a method of communication is called as half duplex. The third method of communication or the third type of data flow, we call it as full duplex. In full duplex communication, two machines, that is the sender and the receiver, can communicate in both the directions simultaneously. That is, sender can send, at the same time receiver can receive. So once the sender will become when a source is generating the data, it becomes the sender, the other end becomes the receiver. When the other end is generating the data, this end becomes the receiver, the source becomes the sender. So data flow can happen in both the directions at the same time. That is why you all can have a look at the third figure. You have a station on the first side, you have a station on the other side, and look at the arrow. Arrow is a double-headed arrow. Double-headed arrow means you can transmit and receive the data in both the directions simultaneously. So you need to understand these three modes of communication, these three modes of data flow. What is the first method or the first mode? We call it as simplex. The second one is half duplex, and the third one is full duplex. What is simplex? Data is transmitted in one direction only, from the sender to the receiver. The other end will not respond, other end cannot communicate, the other end cannot give any acknowledgement. What about the second one, half duplex? You can transmit the data in both the directions, but one at a time. Means simultaneously they can't communicate. Either the sender will send or the receiver will be sending the acknowledgement. So data flow can be in both the directions, but at a time only one of the machines can transmit. Whereas full duplex means both the data sender and the receiver can communicate with each other simultaneously at the same time and in both the directions. Okay? Neha, mute yourself. Okay. Now what we have to understand is what is meant by the term network. Now we have learned this term in the previous semester also. We know what is a network. A network is a set of devices or nodes which are connected together with the help of a communication link. What is a network? A set of devices, maybe electronic devices, which we generally call as nodes. These set of devices are also known as nodes. Okay, and they are connected by a communication link. They are connected by a communication device. Okay, now, a node can be a printer, it can be a computer, it can be a laptop, it can be a mobile phone, it can be anything. Any device which is connected in the network is called as a node. So, your network could consist of computers and mobiles, it can consist of PCs and laptops, it can consist of digital assistants and other devices. Any type of device which is able to generate the data, we call it as a node. If it is connected to the network, it is known as a node. Okay. Now, networks can compute or they can be implemented by making use of what we call as distributed processing. Many a times, many organizations, they have this requirement of large amount of data that should be processed, and for such a requirement to be fulfilled, generally many organizations make use of distributed processing. Now what is meant by distributed processing? A task that needs to be done is divided among multiple computers which may be geographically located in different places. That means instead of storing all the data on one machine, the data can be stored on multiple machines, and the processing can also happen on multiple machines. So say for example, I'll give you one example. Say for example, you are using internet and you are using the Google search engine, and you are trying to search for some maybe a keyword, or you are trying to search for something. The moment you type something in that, you immediately get the result. Now the Google servers that are operating, they could be implemented in a distributed manner. That is, they need not be your processing need not be centralized. The servers can be distributed in different places, and from there you are able to access the data and make the data available on your machine. So distributed processing, there are a lot of advantages. One is you can replicate your data, and your in case of a failure, if at all your network fails, you will still have some or the other possibility, some or the other server which can take up in case of a failure. So it's like, backup system. By chance one of the server fails, your network is not going to be down. In fact, your network can still operate because you are making use of say a distributed processing system, which will allow the processing of data to be done on multiple devices. Okay. Now there are certain criteria which we can make use of in case of a network to understand its performance. Now if at all you have a network, how good it is, how well it operates, that we can check with the help of certain criteria. Criteria means conditions. There are certain conditions that your network satisfies. Depending on that, you can decide the reliability of your network, the performance of your network. Okay. So the network, whether it is a good one or no, we can decide based on performance, we can decide based on reliability, and the third thing, we can decide based on security. Okay. Now what do you mean by performance? Say suppose you have a network and it is operating 24 by 7. Then if at all your network doesn't crash, if at all it is responding, it is giving you the data or the necessary information in very little time, then the performance of the network is good. For example, suppose you have a 3G or a 4G connection, and you are trying to type something in Google and trying to access the data. You all must have observed with a 4G connection, or maybe nowadays with 5G connection to certain extent, immediately you will get the data on your screen. Response is very fast. What does that mean? Performance of a 5G network is better than the performance of a 2G or a 3G network. So when your access time is less, response time is less, throughput is more. Throughput in the sense the number of packets that you are transmitting. If it is more, the performance of the network is good. Second important criteria is reliability. How reliable your network is. If your network is crashing again and again, if it is failing again and again, it is getting corrupted again and again, definitely the network is not good. But suppose, in spite of a crash, if your network is able to recover, if your network is not failing again and again, then definitely the network is good. The third important criteria which decides the performance of a network is its security. Whenever you are transmitting the data from one point to another, you do not want outsiders to have access to data. So there could be hackers, there could be people who can peep into the network and get your data, and they can make changes to it, or maybe intentionally some changes can be done in order to see to it that your data doesn't reach the destination correctly, especially if you have a military network or the defense system of a particular country. In that case, security of your data is very, very important, not only in defense, in general also. Suppose I'm trying to access my bank account, and suppose I'm trying to check my balance, or I'm making an online payment through my credit card or through my debit card. Whenever I give my password or I'll give my PIN number, it should remain secure, so that nobody else should be able to get access to my bank account, and my data should remain safe. So in such a case, what is required is procedures. We require certain subroutines. Some standards are required, which your applications must satisfy, especially if they are working on the network, in order to ensure reliability. So there are three criteria that define the network performance. Three criteria for a network. One is performance, second is reliability, and the third one is security. Okay. Now, whenever we have a network, we can distinguish those networks depending on the type of connections. Now, there are different ways of uh, uh, categorizing your networks. Like based on area, you can categorize them as LAN, WAN, and MAN. Depending on the type of topology, you can have mesh topology, ring topology. But generally, whenever you have two or more machines which are communicating with each other, then we can classify the networks basically into two types depending on the type of connection. One is called as a point to point network, and the second type of network is called as a multi point network. Okay, so depending on the type of connection between two or more devices, we can classify our network as a point to point network, or it can be classified as a multi point network. Can you all see the diagram on the screen? Have a look at what is meant by a point to point network. In a point to point network, there is a point to point link, there is a point to point connection between two machines. Can you all see? We have a station on one side, let's call it a sender. We have a station on the other side, we can call it as the receiver, and both are connected via a link or maybe some kind of a medium. This method of connecting two devices using a link between two adjacent devices is called as a point to point link. Can you see? This is first machine, this is the second machine, and there's a link between the two. That is why it is called as a point to point link. Look at the second type of connection or the second type of network. We can have the networks which are called as multi-point networks. Okay. Now, what are multi-point networks? There can be one machine and there can be multiple points at which that network is tapped, and multiple stations or multiple clients are connected to it. So you all can see there's a mainframe which can be a server, and there can be other stations which can be clients. So you can have a client server architecture. All of you can observe there are multiple points, first, second, third. Now there is this particular line, this particular link from the mainframe is tapped at first point, second point, third point, and so on. Can you see multi-point links there? One channel is there, but multiple links are there, or multiple drop lines are there, multiple tapping points are there. So this kind of a connection is called as a multi-point connection. Multiple means more than one. So can you see more than one stations being connected via a mainframe and via a link? You should understand this distinction between networks very clearly. Is it clear what I have told just now? Whenever you have networks, we can distinguish them, we can categorize them into two types. One is called as point to point connection. Depending on the connection, we can call it as point to point network, or we can call it as a multi point network. In point to point network, there is a link between any two adjacent machines, direct link. Whereas in a multi-point network, there can be one server and multiple machines which are connected to that server via multiple points or multiple taps. Okay. Such a network will be called as a multi-point network. Okay. Now, whether it is point to point or whether it is multi-point, we can arrange our network in a specific way. Geometrically, we can connect the devices together in a particular method, using a particular method. That is called as topology. Topology is a term which describes the way in which the network is laid out physically. Laid out physically means physically how are the machines connected together. So suppose you have a computer lab. Suppose the machines are connected in the form of a ring, then it is called as ring topology. If there is one channel to which multiple devices are connected, then it would be called as a bus. If there are multiple devices which are connected to a hub, then it will be called as a star. Or there can be a mesh topology. Mesh means grid. Any computer is connected to any other computer. Such a topology can also be there. So depending on how the machines are connected together in a network physically or geometrically, what kind of a shape or pattern they are creating, that is called as topology. This is an important term for exam. Generally they ask you this term for 2 marks. What is topology? Give examples. What do you mean by the word topology? The way in which a network is laid out. Laid out means connected. The way in which a network is connected physically. Physically, what kind of a shape or what kind of a geometrical pattern that network is giving you, that is called as topology. So can you all see topology can be of different types? One is mesh topology, second one is star topology, third is bus topology, and the last one is called as ring topology. Okay. Can you all see what is a mesh topology? Mesh means a net. What do you mean by the word mesh? Net. Any computer is connected to any other computer via a point-to-point link. So can you see station 1? You can, on top, what is there? You can call it a station 1. This is station 2, 3, 4, and 5. Can you see there are point-to-point links? And can you observe between each pair of devices, there are point-to-point links? There is no specific pattern. So all the machines, any machine can be connected to any other machine directly or indirectly. When there is no specific shape, no specific geometrical pattern, we call it as mesh topology. Okay. The second one is called as bus topology. Now I think last semester I had told you about Ethernet. Ethernet makes use of bus topology. Can you see the bus topology? In case of a bus topology, there is one channel to which multiple stations are connected. Can you see station 1, station 2, station 3? They are all connected to this cable. So there are drop lines or connecting lines that connect the station or the machine, the PC, to your channel. And there are taps. Taps in the sense the machine gets connected to the main medium at some point using a particular device which is called as a tap, which will induce that machine into the network. If that tap is not there, then the machine becomes a standalone machine. So using the tap, we are able to induce the machine inside the network. Similarly, the second station, similarly, the third station, all of you can see there is a common channel, common cable to which multiple devices are connected. This kind of a topology is called as a bus topology. Then the same bus topology, if you connect both the ends which are open, both the ends, if you connect them together, then it will be called as a ring topology. Can you see a ring topology? In case of a ring topology, the machines are connected in the form of a ring. Each station is induced into the network with the help of a tap, or what we call as a repeater, as and how the machine, as and how each of the machine gets connected to the network, the data can be transmitted from one point to another. So from one station, for example, this is station A and this is station C. From A to C, using this ring, using this cable, the data can be reaching C. So from A, it will via cable, it will go to B, the repeater will see there, it is not for B, so it will simply forward the data and allow it to reach C. When it is addressed to C, C will be able to accept the data. This topology, wherein all the machines are connected in the form of a ring, is called as ring topology. Okay. We have the third, one more type of topology, which is called a star topology. Now, star, you may feel it looks like a star, but in case of a network, a star topology is one in which there is a common hub. A hub is a kind of a device to which multiple machines can be connected. So this hub has got many ports, and each machine can get connected to the hub via the port. So suppose A wants to send to data to B, A will first send it to the hub, hub will in turn transmit it to B. Or suppose A wants to send it to D, A will first send it to the hub, hub will transmit it to the D. So what is most important factor or most important component in this network? The hub. If the hub fails, the network capacity is going to be lost, because hub is the main thing that connects them together. You can have hubs which have got 32 ports, or maybe even many ports are there. So depending on that, with the help of the hub, we are able to connect the computers together. So the transmission facility is implemented with the help of a hub. This kind of a topology is called as a star topology. Then we can also have a type of topology which is called as hybrid topology. Now in hybrid topology, two or more topologies are implemented together to give rise to a new topology. What do you mean by the word hybrid? Hybrid means not pure. So if you have two or more different topologies that are put together, then it will be called as a hybrid topology. Can you all see this diagram? Look at the first line, it is the bus topology. Second line, it's a bus topology. Third line is again a bus topology. So three buses we have, they are connected together using a hub. So now you have a star plus bus topology, giving rise to what we call as a hybrid topology. Understanding what is meant by hybrid topology? A bus topology is there, another bus topology is there, another bus topology is there. Suppose station 1 from say first bus want to transmit data to station 1 from the third bus, then it has to first send it to the hub. Hub will transmit it to this particular bus and in turn to this particular station. So you can see two topologies we have used here, the bus topology as well as the star topology, that is a hub is used together, it will be called as a hybrid topology. Okay, I hope I am clear. I'll quickly revise what I covered today, then you can ask me if you have any doubts. We understood what is data flow. In a computer network, there are three types of data flow, that is simplex, half duplex and full duplex. Simplex means data transmission is in one direction. Half duplex means both the directions but one at a time. And full duplex means both the directions at the same time, simultaneously. Then we know what is a network, we know what is a node, we know the meaning of the word distributed processing, and we know there are different criteria to measure the performance of a network. I have also told you we can classify the networks based on the connections as point-to-point connection and multi-point connection. And we can have a topology, the way in which the computers are connected physically, we call it as a topology. There are different types of topologies like mesh, star, bus, ring, and also hybrid. See the mesh topology, like a grid or a net. Bus topology, one cable to which multiple machines are connected. Star topology, multiple machines are connected to a hub and via the hub data is transmitted. Ring topology, data is the cable is connected in the form of a ring and multiple machines are connected to it. And hybrid topology, where two or more topologies are combined to form a new type of topology. So in this diagram, we have bus as well as this hub, that is star. Okay, together it will give rise to hybrid topology. Okay, now if you have any doubts in what we learned just now, you people can ask me. Now, a lot of people have joined me late today. Why have you people joined late? Those who have joined late, I am very sorry. I will not be able to give you attendance. Okay. Only first 48 people will get the attendance. 47 people will get the attendance. If you join on time, then only you will get attendance. Otherwise, no. Okay. Whatever we learned today, did you understand or you want me to repeat something? If anybody has any doubt, raise your hands or you can unmute yourself and ask me. Nobody has any doubts? That means everything I taught you understood. Or you didn't understand at all. What is it?
Understood, ma'am.
Understood. Sai Prakash is understood. What about others?
Understood, ma'am.
Understood. Okay. No doubts? Okay. Maitri is asking, repeat the meaning of the word hub. Generally, a hub is a centralized point which has got lot of ports, and just like you have a USB port to your computer or to your mobile phone, you can connect there, no? You can connect a cable there. Like that, you have seen a spike buster. I don't know if you people have seen a spike buster. A big spike buster with multiple sockets in it. Have you seen?
Yes, ma'am.
Yes, ma'am.
That is a hub. That is similar. It is not a hub. Similar to that is a hub. Hub has got the capacity to check the data that comes over incoming line and forward it to the appropriate outgoing line. It's like a switch only. You people have learned about switches in the previous semester, no? Circuit switch. Then we learned about packet switch. It takes the data over the incoming line, checks the address and forwards it over outgoing line. So hub is a device which has got multiple ports. When the data comes over the incoming line, it will check the address and forward it to the proper outgoing line. All right, that is a hub. Pranay is asking me, ma'am, in mesh, all devices should be connected to all devices or any to any. Okay. Actually, in mesh, there is no hard and fast rule. In the diagram which I showed you, that is this diagram, between every pair of devices, there's a link, but that is not hard and fast. Any device can be connected to any device. In this example, between every two devices, there's a link. Okay. So it is not compulsory that between every two devices, there should be a link. No. Any device can be connected to any other device. In mesh topology, the advantage that we get is there are alternative lines, alternative paths over which we can transmit the data. For example, suppose A to B, there is a connection, direct connection. You all can see here. Okay. Suppose this link breaks. Then what we can do, we can send it from A to C and then from C to B. So there's an alternative path. So in a mesh topology, there's no hard and fast rule that you should have pairwise connection. Any device can be connected to any other device. If there is a direct link, data will be sent via direct link. If not, via a indirect link. The advantage that we get in a mesh is we have alternative paths over which we can transmit the data. Okay. Preferably you unmute yourself and ask instead of posting your questions. I will not mind. The reason why I'm asking you to unmute and ask me is, in the chat box, whatever your numbers are entered, no, we are taking that data in Excel, and from there we are inputting, we are taking your attendance. So if you put sentences, no, then it becomes little